Someone sent this chart to me because it was giving them anxiety. And so I wanted to explain to you why I look at this chart. And while, yes, there's a huge increase in CO2, and this can seem nerve-wracking, I look at this and I have no anxiety whatsoever about climate change. So I'm going to take you through my reasoning. So this chart shows global atmospheric CO2 concentrations going back to 800,000 years ago. And before we started burning oil, coal, and natural gas in the last 200-ish years since 1850, we were at a steady level of CO2 for those 800,000 years, around between 180 parts per million to 300 parts per million. And today we're at 426 parts per million. So within this time scale, yes, this looks extreme. But if you zoom out and take a longer time scale, you can see going back millions of years that our current CO2 levels are historically very low for the history of the planet. And, hundreds of millions of years ago, CO2 levels were very high, up to 800,000 parts per million. Around the time of the dinosaurs, they were about between 2,000 and 3,000 parts per million. And then over the past 100 million years, what's happened is that the CO2 that was all in the atmosphere has been getting sequestered through natural processes because our planet has a carbon cycle. So this is the natural carbon cycle. There's so much carbon cycling all the time. Humans are 18% carbon, okay? So CO2 is just 1 part carbon, 2 parts oxygen, and it goes through the plants through photosynthesis. So when there's like an algae bloom, a lot of CO2 gets taken out of the atmosphere, grows those algae. And what happens is over time, those algae sink to the bottom of the ocean, layers and layers of that over hundreds of millions of years. They then get moved around by tectonic plates and crushed, and they end up making the fossil fuels that we use today. So what's happening is we're burning ancient carbon life that took that CO2 out of the atmosphere, sequestered it, and now we're burning it. And so that's why those CO2 levels are now going up. But of the CO2 cycling in the atmosphere at any given time, 95% of it is naturally occurring. Again, I'm exhaling CO2 right now. Plants take it in. It's a naturally occurring thing. The only thing that we're doing is we're taking CO2 that has been sequestered by natural processes over millions of years, and we are returning it essentially to the atmosphere. So we know CO2 is a building block of life, and a side effect of all this added CO2 is that we're seeing global greening. And this map is actually from the NASA website, and on there they say they've seen significant greening over the past 40 years since 1980. And what's crazy is that the greening represents an increase in leaves on plants and trees equivalent in area to 2 times the continental United States. So this has been a kind of unexpected but really positive side effect, is that the planet is greening because plants now have more CO2, and so photosynthesis is happening more efficiently. They're growing faster, they're growing bigger. So the reason why this is happening, and we're all going to go back to, 9th grade biology class for a second, is because when plants perform photosynthesis, they're waiting for CO2 to come into their stomata, which are pores on their leaves. And when there's less CO2 in the atmosphere, they need to make more pores, and they need to have those pores open longer. And so what happens is the whole photosynthesis process requires more time and more water. With more CO2 available, basically we've essentially doubled the amount of food in the atmosphere for them. They have less stomata, which means they release less water, so they're more efficient overall at performing photosynthesis, which is so cool. And in fact, right now, the CO2 levels that we're at 420 parts per million, is still lower than the ideal rate for many plants. So in this chart, it shows 2 different types of plants. We have C4 plants, C3 plants, don't really need to know. But for C3 plants, which are the most common plants that we grow and eat every day, we're not even at ideal photosynthesis for them. We would actually need to get to 800 parts per million for them to be at their ideal optimal photosynthesis levels. And we're only at 420. Here are some other levels of CO2 you can think about. So again, it's a trace gas. It's only happening, like if you were to take 1 million molecules in the atmosphere, you'd only find 426 CO2 molecules out of 1 million. That's how trace of a gas this is. And so at different CO2 levels, different things happen. So in greenhouse growers, they'll add CO2 to their greenhouses up to 1,200, 1,500 parts per million, just to get all those benefits of the plants growing faster. We exhale CO2 around 38,000 parts per million. Again, humans exhale CO2. We know animals exhale CO2, and plants, take in CO2 and release oxygen. Remember this from class? And one more thing from this side, below 150 parts per million, all life on Earth ceases because there's not enough CO2 for plants to perform photosynthesis. So the final thing we need to discuss is the warming, because I know that's really a sticking point for the anxiety because everyone's talking about that. The greening stuff, added bonus, but what about the warming? So what I did not understand when I was in the climate movement is that CO2's warming impacts are logarithmic, which means they diminish over time. It's actually the opposite of exponential. It's logarithmic. And so basically, Each additional CO2 molecule has less impacts on warming than the molecule before it. A way you could think about this is, say you have like a window and you're trying to block the light from coming through the window, and you're doing it with dots that are stickers, and each we'll say these stickers are like CO2. Each first CO2 sticker dot that we're putting on the window is going to block a lot of light, right? But eventually the window will be covered with stickers and no light will be getting through. So as I'm adding more stickers, the light's blocked. The work is done. And that's what CO2 is. So those first 100 molecules, parts per million molecules of CO2, are doing a lot of the greenhouse warming impacts that this planet needs to be the difference between being this and frigidly cold. So it's doing something really important. And then after even that first 100, when you get to 200, 300, 400, we have diminishing returns. And right now we're at 426 parts per million. And there's a calculation in physics that says if we were to double CO2, we would only see about 1 degree Celsius of warming. And this is agreed upon calculation that they've done. It's more complex than I think we need to go into in this video. But to go from today's present day 426 parts per million of CO2 to 850 parts per million of CO2, we're only going to see 1 degree of warming. And because we add about 2.5 parts per million of CO2 per year, we actually had 5 parts per million, we add 5 parts per million, but half of it gets sequestered naturally. So we're adding about 2.5 parts per million of CO2 per year. And so if you do the math, it will take about 175 years to get to that 800 number. And so we have 175 years, we're going to see 1 degree of warming. And then after that part, we'll have the 850 parts per million. Say we even get there. We may never get there. We might get new technology that never happens. But say we do, to get another additional 1 degree of warming, we would have to get to over 1,600 parts per million, which would take even longer because, again, it's taking longer to double every single time. Okay, so we're back at the original chart. Now we can see over 800,000 years, which is just a small segment of the Earth's history, we've had parts per million of CO2 be between about 180 and 300. Now we know that below 150 parts per million, all life on Earth ceases because photosynthesis stops. And so what we've done is added CO2 into the atmosphere that previously was in the atmosphere millions of years ago. We basically returned it to the atmosphere, adding to CO2 fertilization, making plants photosynthesis more efficient, and minor warming that diminishes over time.